I'm Joanna Junak and welcome to another edition of Science Episode featuring Roberto Sussman. Today, Roberto will tell us about the byproducts formed when e-liquids are heated and how they differ from those in tobacco smoke. Roberto, how does it work?
That's the $1 million question. Now, look, when you heat the liquid, right, and that can happen to any liquid. It's not special to the liquids used in vaping. Any liquid, if you heat it, you generate reactions, right? The reaction is interaction between molecules that will produce something new, right? Sometimes they're reversible. The something new goes back to what was before, but in all these reactions depend on the temperature. Well, I'm simplifying a bit, but I'm talking about chemistry that is not superfluids or very critical conditions, right? No, the normal chemistry and conditions that we have in the environment, right? So temperatures depend, reactions depend on temperature, especially if you are doing it in the liquid, right? You're heating the liquid, so as the liquid boils, right, evaporates, it has gone to a temperature, say 250 degrees, because of the mixture, has gone 250 degrees. So the reaction depends on the temperature in a very special way. It is an exponential. If you see an exponential is a curve that is doing like this. Almost no growth here, almost no growth, and suddenly, boom, you know. Let me see if I can, so like this, it grows, right? Grows. So it depends on the temperature. If vaping is taking place in the right temperature, it will be in the part of the exponential that is of slow growth. That means that some byproducts will be produced. Mostly, these are byproducts of the solvents. That is, either what happens here in this type of reactions are called low energy pyrolysis. Well, pyrolysis is when you have a big molecule, you heat that, and the molecule breaks down into smaller molecules. This is pyrolysis. But pyrolysis can be extremely energetic. It is part of combustion also. But in this case, and for this type of molecules, it is a very low energy pyrolysis. It is also called thermal degradation because you have the molecule of propylene glycol breaking into smaller molecules, propanaldehyde, etc. There are several molecules that it breaks down. And glycerol is a bigger molecule, so it will produce more. And it is this process. But this process depends on the temperature for each reaction, right? And so in the temperatures that vaping takes place, the reactions are in the very slowly increasing part of the exponential. So what you have is that a few byproducts, typically the byproducts that are produced by the solvents, are aldehydes. It's a family of chemicals, or volatile chemicals. Volatile, they evaporate easily. And normally the largest, they produce in very small amounts because the temperature is not enough to reach the exponential part. See, the reaction is here, right? It will go a little bit. It will not go to the exponential part if vaping is done in the right temperatures, right? And the largest concentration is normally formaldehyde. Formaldehyde is the largest one, but it is still very minute, right? It is still very, very minute. I will compare now with cigarettes. Now, this, so not, I'm simplifying a little bit because the flavor chemicals also produce byproducts. Some flavor chemicals, they do not change. In this range of temperature, they go to the gas, and I don't know if you understand that all these byproducts will be in the gas because they produced by the boiling. They are no longer in the liquid, but they are in the vapor, right? So these are gaseous reactions, right? And the flavorings will also produce their own. But what happens is that some people say, oh, flavorings, we know that they are no problem if if you eat them, if you ingest them, no problem, but we don't know what happens is, yeah, in some cases it's true, but the amounts are so small because, flavorings typically do not make more than 8 or 10% of the liquid. And that's exaggerated. I know that some black markets might put 20, 30% of flavoring. And that is bad. That is very dangerous. That's why the regulation is needed, right? Because the flavorings, when we talk about flavorings, we are talking about a jungle of chemicals, a real jungle of chemicals. So it's not so easy to have a regulation on that, but it must be. Now, okay, so this explains the byproducts. They're produced, they're toxic, but in the quantities, in the doses that they're produced, they are minimal. I'm not saying there is no harm, nothing like that, but it is minimal, right? Also, metals, that's another issue. I'll talk about that. Some metals in the form of nanoparticles, very tiny particles, they also move into the vapor, but they are tiny. We're talking about maybe one of these molecules for every 100 million of the others, or 10 million of the other droplets. So, but let's talk about cigarettes. In the case of cigarettes, the thermal processes are much, much more complicated, absolutely much more complicated. That requires a special, a special session to describe them all. But as I said in the last part, the cigarette, the tip of the cigarette is at 950 degrees, and the user will get the smoke at 40 degrees. So you need a lot of processes that have to absorb a lot of energy, and every one of these processes involves condensation, evaporation, distillation when you pull up the gases and the particles, also pyrolysis and pyrosynthesis, because molecules break down and the parts recombine and do something else, right? So it's very complicated. And formaldehyde is just one. See, in vaping, formaldehyde is the big villain. Formaldehyde is the monster. But in tobacco smoke, formaldehyde is nobody. It's just one of many. They are much more toxic. For example, there's a family, the aromatic hydrocarbons. These are fat molecules, carbon made of carbon and hydrogen, and very big molecules. And these are really bad. If you want to pin down to cancer. These are then others, amines, phenols, and they're complicated molecules. They are organic molecules. You also have inorganic material because a cigarette is burning, like cigarette has cellulose in the filter and the paper, and then the metals also are there. How do the metals get into the cigarette? Because the metals are already in the tobacco plant. The tobacco plant is in the air. Metals don't come from outer space or from another galaxy. Metals are in the atmosphere, right? So they hit in very tiny amounts, and this and also nitrosamines are also some of the nitrosamines might also be already in the tobacco plant because it's reactions of amines and the nitrogen in the atmosphere. So, but anyway, to cut it short, the for example, let's say formaldehyde. Typically, it will be 1%, the most, may 1% of the abundance in tobacco. See, it is difficult to say that because it varies from tobacco. Not all cigarettes are the same. There are variations among the brands and so on. And also not all the vapes are the same. But roughly you can say that formaldehyde in vaping average will be between 1 and 2% of what you find in the tobacco. Okay? But, for example, if you take another one that is called acetaldehyde, acetaldehyde is also an aldehyde that is also carcinogen, it's also terrible, very bad. And in tobacco smoke, it is hundreds of times, it is uh, orders of magnitude more. It is much worse than formaldehyde, right? And then what is important is that about 98, 99% of the compounds that are detected in tobacco smoke are absent. See? For example, you say 7,000 detected compounds in tobacco smoke. But again, I emphasize this, a lot of these thousands of compounds are barely detectable. This is the limit of detection. They are maybe here, right? Maybe here. If you have more sensitive instruments, you detect more, but that's irrelevant. Anyway, 7,000, let's say. And in e-cigarettes, in the aerosol, you detect maybe 150. That's, again, I emphasize it depends on, but I'm just talking about orders of magnitude. Thousands of compounds, 150. And also, the byproducts that are more relevant, because if you take the e-cigarette aerosol, basically the mass will be 98, 99% glycerol, propylene glycol, nicotine, water. That's it. That will make like 99%. But that's not the case in tobacco smoke. In tobacco smoke, you cannot identify four compounds that will make 90% to 98%. Tobacco, the chemical makeup of the mass is very complicated. It's about 10% or 20% water, and then it's carbon monoxide, and all sorts of things. It's complicated, right? I mentioned another thing I have to mention if we talk about tobacco smoke is the particles. Particles are completely different. What we call tar is tobacco aerosol residue. So in laboratory experiments, they puff the cigarette with a machine and they pass the smoke that they are puffing through filters. These filters remove water and nicotine, right? And what remains is called tar, and it's supposed to be liquid particles. But tobacco smoke has also solid particles because every one of these processes will produce one type of particles. In a sense, you can say that tobacco smoke is a mixture of many aerosols, many small. Anyway, in the end, you take it as one aerosol, but the amount of compounds that are toxic is inherent to the thermal processes because, again, I emphasize, I go back to the beginning, you have to cool something that was produced at 950 degrees, you have to cool it in 10 centimeters, in a rod of 10 centimeters, that has to be cooled to 40 degrees. 40 degrees. So it is chemically very complicated, produces a jungle of compounds in large quantities and so on. And what we regard as a horrible villain, that formaldehyde, is just a novel in tobacco smoke. In tobacco smoke, then there are maybe 1,500 compounds of the same level of concentration of formaldehyde that are equally or more toxic. And so this is what we are comparing. We're comparing 4 billions that appear in small quantities with 1,000 billions that are much stronger than they. So that's a good analogy. You have a village, and the village is going to be invaded by 4 little guys. They're very bad, but they're very little guys, and they're going to invade. So in the order, your village is going to be invaded by 1,500 big guys, and also very bad guys, but very big. So which village do you prefer to go? That doesn't mean that these 4 little guys cannot do any harm. They can do any. But the harm they will do will never, never be comparable to the harm the others can do.
Stay tuned for the next part of our science series coming in a couple of weeks.